Okay guys, in this example 3, we have what we call denominator with repeated root, repeated factor. So repeated isn't mean that you have a linear, which is x minus 2 square. Because of the square we call it repeated. Depends, sometimes you could have irreducible quadratic here instead of a linear. So it kind of like works according to the rules like what I already discussed. Okay, let's see. So first write down that algebraic fraction here. So as you can see, since this is the first linear factor, so I give a constant a over that first linear constant. Now you put a b because you're going to take one of that, okay, one of x minus 2, because x minus 2 square. So again, the third one, you pick a c and put x over 2 square. Why? It's kind of like it works. Okay, so just remember that when you have repeated roots, if it's repeated twice, you're going to have 2b and c. If you have x minus 2, let's say you have x minus 2 cube, you're going to have b over x minus 2 plus c over x minus 2 square plus d over x minus 2 cube. Okay, so most probably going to have a twice repeated. Okay, all right, so after you have done that, after you have this particular form, so I'm just going to consider the numerator because denominator is the same for left hand side in the process. Okay, so you can see that a should be multiplied by x minus 2 square, because now in this term you can see that it's lacking of this factor here, so I just multiply by that so that the whole thing here will have the same denominator as this part. So I have that, then plus b is lacking of 1 x minus 2 because here is x minus 2 square, so I have to multiply by x minus 2 here. Then again, this one is lacking of 2x plus 1, so I have that. Okay, then plus c, I have the x minus 2 square, I just don't have 2x plus 1, so that's why I multiply by that. So now you let x equals to 2y, because I can see that from here that this one is going to be 0, this one is going to be 0, so I have only with c. So if you put 2, you can see that this one is coming from 2 times 2 plus 1. Okay, 2 plus 1 is 5, so I have 5c there. So you do correctly, you will have c equals to 11. Okay, then again, this one is I substituted x equals to negative half because of this factor. Okay, so if I put negative 1 over 2 as x, I will have 0. So 0 is good. Okay, 0 is good. You make things simplified to dramatically. Okay, so you have that, you put x equals to negative 1 over 2 here, also same. So you can see that immediately the second and the third terms vanish, so you have a equals to negative 4. So use your calculator if you want. Okay, next, again, because I already I don't know what to substitute already after I have substituted this value. Again, the best guess of x that we normally do is x equal to 0 or 1. Okay, because it's easy. So you put x equal to 0, you can see that the left hand side becomes 0, 0 and negative 11, equivalent to negative 4. Why negative 4? Because a is negative 4, so this is a, so times x minus 2, so this one is coming from x minus 2 square, because this is 0 minus 2 square, you have negative 2 square. Okay, so again you have the b here, and c is equals to 11, so this is c, so this is c. Okay, so times 1. Okay, so you have b equals to 3, so you just write down this one as that. Okay, you can just compile this. We have negative 4 okay, over 2x plus 1 plus 3 over x minus 2 plus 11 over x square, x minus 2 square. Okay, all right. What if you have uh, in the second videos that I write down something I erase, but I said I would like to keep it in the third example as well. So let's say you have this, okay, you have that plus 29x minus 11, 2x plus 1, and this one is x square, what is it, x square plus 3x plus 3x plus 5 square. So this one is irreducible quadratic, so you should have right a over 2x plus 1 for the linear factor, plus now because the irreducible is repeated, so irreducible plus repeated, so what you do is bx plus c for the irreducible quadratic, okay, then plus dx plus e over x square plus 3x plus 5, so square. All right, the numerator is 1 degree less compared to the denominator. So I hope that helps. You can generalize these four simple rules in any algebraic. Yeah, I think most. I think most of the algebraic um, fraction. So that's it. Yeah. Okay. All right. Maybe I add up a little bit more. Okay, so please watch the last video first before you and come back to this part, because I think this is what I um, just realized. What if after you look at the example 4 or video 4, what happen if I have on tops looks like 4 and the denominator looks like a 2. So now you can see that I have okay, you have that one, so x3 and x2. What happen if the numerator looks like x4 and denominator looks like x3, and this one is x cubed and x squared? Okay, so now because the okay, let's discuss this one first. Okay, since the degree is one more, so you should have a linear, so please do this. Okay, then plus whatever you have here, okay, depending on your algebraic fraction. So in this one, because it's a difference of 2, okay, so I have a x square plus bx plus c, then plus d of something and something. Okay, so please watch video 4 first before you listen to this part. Okay, so I think that's most of it. So good luck. I hope you can do well in your partial fraction, because it's very fundamental. Okay, thank you.